Okay, so right now we are solving logarithmic equations. We have four problems here. Just like solving exponential equations, with logarithmic, you kind of need to isolate the log, the base, and the arguments. Okay, everything else outside of that, you have to move to the other side. Okay, so for instance, this number one, you have the log, the base, and the argument. So that's good, but for number two, you see this log base argument, but the 4 is an extra. So you need to get rid of that 4. Number three, you have the log. You don't have a base, so that means that's base 10. And this is the argument right here. So therefore, you need to get rid of 5. So that's what I'm saying. So you need to isolate the log, base, and argument on one side, everything else on the other side. Okay, so let's try number one. If you have log, you have to convert it into exponential. Just like when you have exponential, you convert it into logarithmic. Okay, so now number one, you have log base 2, and your argument is x plus 1 equals 4. Now, if this is your base, remember the idea is if you have log base x equals y, this becomes, if this is your base, if you want to change it into an exponential, you start with your base and then your exponent, which is the number outside of your after equal sign, and then this is equal to the argument, everything here. Okay, so now which one is the base here? We want to convert this into exponential. You start with 2, and then so that's 2, and that's the exponent right there to the power of 4 equals this whole argument, x plus 1. And so now what is 2 to the power of 4? That's 16 equals x plus 1. You want to solve for x, so I'm going to subtract 1. So therefore 15 equals x. So that is the value of your x. Okay, so that's it. Okay. All right, let's move on to number two. So number one is a pretty easy one. Let's move on to number two. It says 4 plus log of 2, log base 2, and then that's 6x for your argument equals 1. Okay, so remember, you need to isolate the log, the base, and the argument. So therefore, what does not belong? The positive 4. So therefore, you need to subtract 4. Okay, I'm going to subtract 4. So now what's left is you have log of base 2 argument 6x equals negative 3. Okay, so now we can change this one into an exponential version. So you start with your base to the power of that number right here, which is your exponent, equals 6x. So if you want to, 2 to the power of negative 3 is 1/8, okay, equals 6x. Okay, you can put over 1 here, so you can cross multiply that. Okay, so let's cross multiply. So 6 times 8x, so you have 48x equals 1. You divide by 48 on both sides. So therefore your x is equal to 1 over 48. You can keep it as a fraction, which is a better option. Okay, so let's recap. We kept the log base argument, move everything else. And then once your log base argument is isolated, then you can change it into or convert it into an exponential uh, format. All right, so let's try number 4. Again, my challenge for you is to try it first, pause this, and then check your answer against mine. Maybe I could get it wrong, and then you can write it in the comments to see what I did wrong. Okay. All right. So number 3, you have 5 log x plus 3 equals 100. Okay, now so this is your log, base is hidden, x plus 3 is your argument, so therefore which one does not belong? You have the 5, so therefore that's 5 times log. So to undo that times, you do the opposite, which is divide. So now you have log of x plus 3 equals 20. Okay, now so now we can change it into an exponent, but what is the base? So remember, if you don't see any base here, that means it is 10. Okay, so that means you can change this one to exponential now. You can do 10 to the power of 20. That's a really big one, equals x plus 3. Okay, so let's make this one just for the purposes of this problem. Let's change this 100 to 4. Okay, maybe 10. Let's change it to 10. If we change this one to 10, then this is going to be 2. And so now you will have 10 to the power of 2, which is equal to 100. That's x plus 3. You subtract 3 on both sides. Therefore, you have 97. That's equal to x. Okay, so I changed this equation just because I don't feel like I'm gonna have enough space to do 10 to the power of 20. Okay, so that's the final answer, 97 with our edited. So if you did this one, I pause this, then you'll probably be wondering what's the answer. Okay, so but if I change it to 10, then that's gonna be the new answer. All right, another challenge for number 4. Pause it as you need. I'm gonna answer it now. All right, so you have ln x minus 4 equals 3. Now ln is just log e. So therefore your base here is e. So if you can, there's nothing else here. So this is like your log, your base, your argument. So it's all set up. So you can just change this one right away into an exponential format. So you have e, this is your base, to that exponent right here, 3 equals x minus 4. Okay, so to solve for x, you add 4. So therefore, your x is just e to the power of 3 plus 4. This is a really acceptable answer. However, if you want to get the equivalent value in terms of numbers, let's just try that. E to the power of 3 plus 4. That is approximately 24.08. Looks like it anyway. All right, so this is approximately 24.09 because 0.85, so that will become 0.9. Okay. All right, so this is the approximate answer. All right, so if you have any question, I should probably give you a challenge problem. Okay, let's do a challenge problem. So again, if you do not have a base, that means base 10. If it's ln, that means it's base e. All right, so this is your challenge that you can answer on the comments below. So let's do a log of 5, and I'm gonna put 3 plus 2 log of 5, x plus 3 equals maybe 8. 8, 9. Okay. All right. So that would be my question. Now remember, you have to get rid of not. You just have to keep this. So make sure you do this one correctly. All right. See you and looking forward to your answers.